Let's take a look at some of the problems on the Unit 4 review. For number 1, it says determine whether the following algebraic equation can be written as a linear function. And we have 2x plus 3y equals 7. Okay, I know that linear functions can be written in y equals mx plus b form. And so we can transform this equation to y equals negative 2/3 x plus 7/3. Okay, if you solve for y. And therefore, we're going to say, yes, this can be written as a linear function. Okay, number 2, is the following function increasing or decreasing? Okay, because it's a line, we can look at the slope. And since the slope is negative, that means this function is decreasing. For number 3, if we want to find a linear equation that passes through these 2 points, first thing we can do is find the slope of the line. And so remember y2 minus y1 over x2 minus x1. In this case, negative 9 minus 1 over 3 minus 5. Or negative 10 over negative 2, which is just 5. Okay, then you can use point slope form, which is y minus y1 equals m times x minus x1. And fill in your m, your slope is 5, and the given point, a given point is x1, y1, so I'll use the 5 and the 1. And so y minus 1 equals 5 times x minus 5. Okay, and rewrite in slope-intercept form. So it becomes y equals 5x minus 24. For number 5, if we're trying to find the slope of the line given a graph, we can just locate 2 points whose coordinates are integers and count the rise over the run. And so I would count down 2, right 1, and so the slope is negative 2. Now, an equation in slope-intercept form is y equals negative 2x plus 2, since the y-intercept is 2. And just don't forget about parallel and perpendicular lines that were also in this first section. And so if I want to find the equation of a line parallel to the given line and passing through negative 3, 4. So again, I decide what the slope of the new line should be. And because parallel lines have the same slope, I'm going to select negative 2 and then use point slope form again. Y minus 4 is equal to negative 2 times x minus negative 3, or x plus 3. And then lastly, convert this to slope-intercept form. So y equals negative 2x minus 2. And we can decide if a table represents a linear function by finding the rate of change between each pair of points. And so I'm going to say change in y over change in x. And start with the first pair. We'll say 32 minus 14, okay, or y2 minus y1, over x2 minus x1, 0 minus negative 6. And simplify that, okay, which is just a 3. And then we do the same calculation with the next 2 points. So 38 minus 32 over 2 minus 0, or 6 over 2, so that's also 3. And then the last 2 points, 44 minus 38 over 4 minus 2. Okay, again, 6 over 2, and so that's also a 3. Okay, because the rate of change is constant, this data does represent a linear function with a slope of 3. Okay, and we also know the y-intercept, thankfully, from the table. Okay, so when x is 0, y is 32. So an equation of this line is y equals 3x plus 32. For number 8, suppose a town's population increases at a constant rate. In 2010, the population was 65,000. By 2012, the population had increased to 90,000. Assuming the trend continues, predict the population in 2018. Okay, so one option is to write a formula for the population over time. We can say 2010 is the year t equals 0, and that means 2012 is, because it's 2 years later, is t equals 2. Okay, recognizing that it says the population increases at a constant rate, that would mean we have a linear function. And so we need to find the slope, or 90,000 minus 65,000 over 2 minus 0, or 12,500. We also have the y-intercept of 65,000. And so population is equal to 12,500 t plus 65,000. Okay, in 2018, that would be 8 years after the initial year of 2010, so we're finding P of 8, which is 165,000. Number 9, it says a car rental company offers 2 plans. Plan A is $25 per day and 10 cents per mile, or Plan B is $40 per day with free unlimited mileage. How many miles would you need to drive for Plan B to save you money? So we're going to write expressions for each of these. Okay, we'll say Plan A is $25 per day plus 0.10 m, where m is the number of miles driven in a day. And Plan B is $40 per day. Okay, so $40 no matter what. And we're just going to set these equal to one another. So 25 plus 0.1 or 0.10 m is equal to 40. But you could instead write an inequality because we want Plan A to cost more and solve this for m. So we find that m is greater than 150. So if you know you're going to be driving more than 150 miles in a day, then Plan B would be the better option. Let's skip ahead to number 12. It says Frank plants a dozen corn seedlings, each 6 inches tall. With plenty of water and sunlight, they will grow approximately 2 inches per day. So we want to write an equation for the height, h, of the seedlings in terms of the number of days that has passed. So h is, so initially they're 6 inches tall, and they're growing by approximately 2 inches per day. So we can say 6 plus 2t. Okay, to make a sketch of this function over time, we just really need 2 points since it's a line. And so one, the y-intercept is a good point to plot, which is at 0, 6. Okay, say when 10 days have passed, we could plug 10 for t, and we get 6 plus 2 times 10, or 6 plus 20, so 26. Okay, so I'll just make a quick sketch, 0, 6, and 10, 26, and connect them with a straight line. Okay, so how tall is the corn after 3 weeks? Okay, so remember our t time is in days. So 3 weeks is 21 days. We'll substitute 21 for t, and we get h equals 6 plus 2 times 21, or 48 inches. In part D, it says, when will the corn grow to 6 feet tall? Well, our height is in inches, so 6 feet is 72 inches. So write an equation, 72 equals 6 plus 2t, and solve it for t. So t is 33 days. Okay, part E, Frank also sets out some tomato plants. The height of the plants in inches after t days is h equals 14 plus 1.5t. What do the constants of the equation tell us about the tomato plants? Okay, so the 14 would be their initial height in inches, and 1.5 is how many inches per day they were growing. Next, we want to be able to solve some systems of equations, and you really have some choices if you are just given a system. So you can graph the two equations, you can use substitution, or use elimination. So we'll take a look at substitution and elimination. Okay, so for number 17, we're going to replace x in the first equation with negative 2y plus 2 and solve for y. And so that gives us negative 8y plus 8 minus 2y equals 18, or negative 10y plus 8 equals 18. Okay, or negative 10y is 10, and so y is negative 1. Okay, we also have to determine the x-coordinate of this ordered pair, and so plug negative 1 into either equation. We'll use the second one, and so x equals negative 2 times negative 1 plus 2, or 2 plus 2, which is 4. And finally, write your answer as an ordered pair. So 4 comes first, and then negative 1. Number 18, we're asked to solve the system using elimination. So if you notice that the x's or y's are opposites of one another, you can just put a line underneath and add. And so negative 2x plus x is negative 1x or negative x. Negative 5y plus 5y is 0, equals negative 5 plus 6, or 1. So x is negative 1. Okay, now we're going to take this x and substitute it into one of the given equations. So I'll choose the second one. Negative 1 plus 5y equals 6. Add 1 to both sides. So 5y is equal to 7, and divide by 5. So y is 7/5. Okay, so the solution is negative 1 7/5. If we're asked to classify a system, then we're really going to determine if the system is consistent or inconsistent. And then consistent systems, there's a couple of options. Okay, the easiest way to tell is to maybe solve both of these equations for y, and so get them in slope-intercept form. Okay, so negative 4y is equal to 1/2 x plus 4. And then if you divide both sides by negative 4, we get y is equal to negative 1/8 x minus 1. In the second equation, we get 16y is equal to negative 2x plus 2. And divide both sides by 16, and we have y equals negative 1/8 x plus 1/8. Okay, now, if the slopes are different, we know that there will be one intersection between the two lines. In this case, the slopes are the same. Also, the y-intercepts are not the same. They're different. So what we've just seen is that these two lines are parallel to one another. If they're parallel lines, they will never intersect, and the system has no solution. So we're going to classify this system as inconsistent. We're going to try to write some systems of equations. So a concert venue sells tickets for $40 each and couples tickets for $65. If the total revenue was $18,090 and 321 tickets were sold, how many single tickets and how many couples tickets were sold? Okay, so we'll let x be the number of single tickets and y the number of couple. Okay, we know altogether, x plus y, there were 321 tickets sold. Well, if single tickets cost $40 and they've sold X of them, then the revenue they've brought in from those tickets is 40 times X. Okay, plus, if couples tickets are $65 each and there's Y of them that are sold, then this is 65Y and is equal to the total revenue, $18,090. Now we decide which method to use to solve this system of equations. If you want to use substitution, we can solve this top equation for either X or Y. And so X is 321 minus Y. And now we'll replace X in this second equation with 321 minus Y. After a little bit of work, we find that Y is equal to 210. And because there were 321 tickets sold altogether, just subtract 210 from 321 and we get 111 single tickets. Let's skip down to quadratics. Okay, for 26 and 27, we want to write the equation in standard form. And so that's going to be y equals a times x minus h squared plus k. So we'll do something called completing the square. Okay, so I have my x squared minus 4x, and then I'm going to put something in this blank, and then bring the minus 5 over, and then I have another blank at the end. So we'll take half of b, which is negative 4, and square it. Okay, and we've done this before, but just when solving quadratics, we've completed the square. Okay, and that's negative 2 squared, or 4. So we'll put a positive 4 in this blank, and the opposite of it in the other blank. Because we don't want to change the value of this expression, we just want to rewrite it. Okay, now x squared minus 4x plus 4 is a perfect square that factors as x minus 2 squared. And minus 5 minus 4 is minus 9. Okay, so it's easy to tell what the vertex is. My h is 2 and k is negative 9. The axis of symmetry is a vertical line that passes through the vertex, and so it's going to have equation x equals whatever h is, in this case 2. So we want to find the intercepts. The good news, the y-intercept is pretty straightforward if you refer back to the initial equation. Okay, so it's just going to be c if this is an ax squared plus bx plus c form. So the y-intercept is 0, negative 5. Okay, the x-intercepts will occur when y is 0. Instead of f of x, just replace it with 0, and we get x squared minus 4x minus 5, and see if we can factor. And so that's x minus 5 times x plus 1, and set each of those factors equal to 0. So x is positive 5 or negative 1. Okay, so one of the x-intercepts is at 5, and the other is at negative 1. Okay, so I may not have needed all of that information to make a sketch, but this will help me determine if my sketch is accurate. Okay, so I draw the vertex at 2, negative 9. The y-intercept was at negative 5. And because of the axis of symmetry, we know there exists another point on the other side of this axis of symmetry equidistant from it. Okay, so I'm going to make another point 2 spaces away at the same height or y-coordinate. And now I can just connect these points with a U-shaped curve. Another option is to notice there was no vertical dilation of the graph. And so if I had known that, and I know it opens upward, I can just count from the vertex over 1 and up 1, and in either direction. If instead we want to write an equation for a given quadratic function, if we're given the vertex, let's start with y equals a times x minus h squared plus k, or standard form. We're going to substitute 2 for h and 0 for k, okay, or a times x minus 2 squared. Okay. But we also need to figure out a, this leading coefficient. So we're going to use 4 and 12, which is an x and a y, and substitute them in the appropriate places. So 12 equals a times 4 minus 2 squared. So 12 is equal to 2 squared, which is 4. So 12 equals 4a, so that must mean a is 3. And now our equation is going to look mostly like this, but replace a with 3. For number 30, it says a company finds that it can make a profit P of P dollars each month by selling X patterns according to this formula. How many patterns must it sell each month to have maximum profit? What is the maximum profit? Okay, so you can kind of imagine what the graph of this function would look like, that it's a parabola that opens downward. Okay, so it would do something like this. Our goal is to find this location, which is the vertex of the parabola. So we have a vertex formula, h equals negative b over 2a. And so we decide what a is based on this given equation. A is negative 0.002 and b is 5.5. So negative 5.5 over 2 times negative 0.002, or 1375. But let's also find k, which is the y-coordinate of the vertex. So substitute 1375 for x in the given function to find 3081.25. Okay, so one of these is the number of patterns, so how many patterns, which is your x coordinate, or h. In our case, 1375. The other one is the y value, or the profit in this case. So $3,081.25. And one of our other sections is on types of variation. So if it says y varies directly as the square of x, we're going to write a general equation as y equals k, the constant of variation, times the square of x, or x squared. And we just need to determine what k is. It's specific to this information. So y is 36 when x is 3. Okay, and if we solve that equation, we get k times 9 is equal to 36. So k must be 4. Lastly, it says find y if x is 4. So we're going to substitute into this new formula, y equals 4. Substitute 4 for x, so times 4 squared, and that's 16 times 4, or 64. Number 34, if we're given a problem involving inverse variation, we're going to write our equation of this form. Y equals, it says it varies inversely as the square root of x, so k divided by the square root of x. When x is 25, y is 2. So 2 equals k over the square root of 25. And we'll solve this equation to find k, that constant of variation. So 2 equals k over 5, and 2 times 5 is 10. So k is 10. Okay, so here is our equation. Y equals 10 over square root of x, relating x and y. And we want to find y if x is 4. So y equals 10 over the square root of 4, or 10 over 2, which is 5.